Redox reactions. Objectives. Define oxidation and reduction. Write oxidation and reduction half equations. Distinguish between oxidizing agents and reducing agents. Redox reactions. The reaction between magnesium and oxygen produces magnesium oxide. In this reaction, magnesium has 2 valence electrons with a charge of 0, while oxygen has 6 valence electrons with a charge of 0. In the reaction, magnesium loses 2 electrons to oxygen, producing a magnesium with a 2+ charge and an oxygen with a 2- charge. A redox or oxidation-reduction reaction involves the transfer of electrons. The number of electrons lost is equal to the number of electrons gained. Redox reactions. Redox reactions involve the gain and loss of electrons. Here, magnesium lost 2 electrons to become Mg2+. The 2 electrons it lost is represented in the half equations on the right side of the arrow, or the product side. Oxygen, meanwhile, gained 2 electrons to become 2-, where the 2 electrons it gained is written on the reactant side, or the left side. The loss of electrons is known as oxidation, while a gain of electrons is known as reduction. Oil rig is an acronym that can be used to help you remember oxidation and reduction, where OIL represents oxidation is lost, and RIG represents reduction is gain. In summary, oxidation is the loss of electrons, while reduction is the gain of electrons. Half equations. In the reaction between magnesium and oxygen, magnesium lost 2 electrons, while oxygen gained 2 electrons. The magnesium half equation is the oxidation half equation, while the oxygen half equation is the reduction half equation. Half equations show the oxidation or reduction part of a redox reaction. Oxidizing and reducing agents. Reducing agent is a substance undergoing oxidation. In this example, magnesium undergoes oxidation, while the oxidizing agent is a substance undergoing reduction. In this example, oxygen is undergoing reduction. Please be careful for this misconception alert. The products are never the reducing or oxidizing agents. Substances that lose and gain electrons are known as reducing agents and oxidizing agents. Oxidation numbers. An oxidation number is a charge of the atom or ion. For example, aluminum in its free state has a charge of 0 because it did not gain or lost any electrons, while oxygen in the free state is also 0 because it didn't gain or lost any electrons. However, in a compound, the oxidation number of aluminum is +3, while oxygen is -2. Aluminum lost 3 electrons to become 3+, while oxygen gained 2 electrons to become 2-. Here, aluminum undergoes oxidation because oxidation is the loss of electrons, while oxygen undergoes reduction because it gained electrons. To balance the equation, we have 4 aluminum reacting with 3 oxygen molecules to produce 2 aluminum oxide. Balancing our equations, we now have 12 electrons being transferred from the aluminum to the oxygen. The substance that undergoes oxidation is known as a reducing agent, which is aluminum, while the substance undergoing reduction is known as the oxidizing agent. In this example, it is the oxygen. Practice question. Write the oxidation and reduction half equations and identify the oxidizing and reducing agents for the chemical reaction shown below. In this example, iron is reacting with sulfur to produce iron sulfide. The oxidation number for iron in the free state is 0, while sulfur is also 0 in the free state. However, in the compound, iron is +2 and sulfur is -2. The iron lost 2 electrons to become 2+, while the sulfur gained 2 electrons to become 2 minus. Since iron is losing electrons, it's undergoing oxidation, while sulfur is undergoing reduction. The iron is known as a reducing agent, while the sulfur is known as an oxidizing agent. Practice question 2. Write the oxidation and reduction half equations and identify the oxidizing and reducing agents for the chemical reaction shown below. Here, iron is reacting with copper sulfate aqueous to produce iron sulfate aqueous plus copper solid. In this reaction, if you were to write the ions present in the aqueous solutions, we'd have this equation. Now, writing the oxidation numbers. Iron in its free state has an oxidation number of 0. Sulfate has an oxidation number of -2, while copper has an oxidation number of +2. Sulfate in the product side has an oxidation number of -2, while iron is +2. Copper in its free state has an oxidation number of 0. Since sulfate has an oxidation number of -2 on both sides, the reactant side and the product side, we can omit sulfate from the equation, since it's a spectator ion and does not take part in the chemical reaction. So now we have iron reacting with copper 2+ ions to produce iron 2+ ions plus copper solid. Iron became 2+. It lost 2 electrons, while copper 2+ became copper neutral. It gained 2 electrons. Since iron lost electrons, it undergoes oxidation, since oxidation is the loss of electrons. While copper gained 2 electrons, it underwent reduction, because reduction is the gain of electrons. The iron solid is known as a reducing agent, because it underwent oxidation, while copper 2+ ions is known as the oxidizing agent, because it underwent reduction.